Attention! This channel provides original historical analysis based on sources and research. We do not simply recount events, we analyze their causes and consequences, explaining them through original narration, editing, and visual diagrams. A list of sources is included in the description. Enjoy watching. Welcome. Today we examine a moment when institutional doctrine met battlefield reality and failed completely. In October 1942, American PT boats in the Solomon Islands faced a tactical problem that existing weapons could not solve. The solution would come not from Washington or Navy bureaus, but from sailors who understood that survival required innovation. This is the story of how desperation created one of World War II's most effective naval weapons. October 21, 1942, 00:15 hours. A 280-pound aircraft cannon sits bolted to the bow of PT-48, salvaged 9 hours earlier from a wrecked fighter at Henderson Field. The mount is crude steel welded from landing gear scrap. The weapon has never been test-fired on a boat. Gunner's mate Harold Mitchell sits behind it with 6 magazines and no training. 4 Japanese barges are moving through the darkness 800 yards ahead, carrying 60 troops each. For 2 months, PT boats have been dying in these waters, torpedoes passing uselessly beneath shallow draft targets, machine guns sparking off armor plate, boats burning under return fire. Tonight, that changes. Mitchell charges the cannon. The first round seats in the chamber. He releases the safety. Nobody knows if the mount will hold, if the deck will collapse, if the recoil will tear the gun free. In 12 seconds, the United States Navy will discover whether desperate innovation can defeat institutional failure. Motor Torpedo Boat Squadron 3 arrived at Tulagi on August 15, 1942, 8 days after Marines seized Henderson Field on Guadalcanal. The squadron consisted of 12 Elco 80-foot boats, each carrying 4 Mark 8 torpedoes. Navy doctrine positioned PT boats as offensive weapons against Japanese shipping, fast attack craft that would strike enemy convoys and withdraw before facing return fire. The doctrine was sound in theory. It had been developed through peacetime exercises against conventional naval targets. It assumed enemies would operate destroyers, cruisers, and cargo vessels with deep draft hulls. The doctrine failed within 72 hours of first contact. On August 18, 1942, PT-37 detected 3 Japanese Daihatsu barges transporting troops to Guadalcanal. Lieutenant Commander Alan Montgomery ordered a standard attack approach, closing to 1,000 yards, the optimal torpedo firing range established through years of peacetime exercises against destroyer targets. PT-37 launched 2 Mark 8 torpedoes at the lead barge. Both torpedoes missed, not because of poor aim or mechanical failure. The torpedoes ran true on their programmed course, passing directly beneath the barges at their minimum depth setting of 10 feet. The Daihatsu barges drew 5 feet of water. The torpedoes never made contact. The weapons passed harmlessly underneath their targets and continued into open water until their fuel exhausted. Montgomery ordered a second approach, with depth settings manually adjusted to absolute minimum, a direct violation of safety protocols that risked premature detonation. PT-37 launched 2 more torpedoes. Both ran shallow as ordered. Both passed beneath the targets. The magnetic exploders, designed to detonate beneath large steel-hulled warships, failed to trigger against small wooden barges with minimal metal structure. 4 torpedoes expended, 0 hits. The fundamental problem was physics, not tactics. The Japanese barges returned fire with Type 92 heavy machine guns. 7.7mm rounds struck PT-37's plywood hull, punching through the thin wooden construction. 1 round penetrated the chart house, killing Quartermaster Second Class Robert Franklin instantly. PT-37 withdrew at maximum speed, trailing smoke from a fuel line punctured by shrapnel. 3 barges continued unmolested to Guadalcanal, delivering 180 troops and 4 tons of ammunition to Japanese forces. The pattern repeated across September 1942. PT boats detected Japanese barge traffic moving down the slot. PT boats attempted torpedo attacks according to doctrine. Torpedoes missed shallow targets systematically. Barges delivered their cargo successfully. American frustration mounted with each failed engagement. The weapons designed to sink enemy shipping could not hit the targets actually encountered in combat. Japanese naval forces controlled the waters around Guadalcanal after dark. Beginning in mid-August, destroyer squadrons ran supply missions down the Slot, the narrow channel between the Solomon Islands, delivering troops, ammunition, and food to Japanese forces fighting for Henderson Field. American forces called these missions the Tokyo Express. The Japanese called them rat runs. The name reflected the mission's purpose, moving supplies quickly under cover of darkness. PT boats attempted to intercept these destroyers with mixed results. On August 20, 1942, PT-60 launched 4 torpedoes at the Japanese destroyer Kagero off Cape Esperance. All 4 torpedoes missed. The destroyer's 5-inch guns returned fire immediately, straddling PT-60 with shells that sent water columns 40 feet into the air. PT-60 escaped through a rain squall, undamaged by luck rather than tactical skill. The engagement demonstrated PT boats' vulnerability against warships with superior firepower and armor. By early September, Japanese commanders recognized that destroyer runs exposed valuable warships to unnecessary risk. American aircraft from Henderson Field could strike destroyers during daylight hours on their return voyage north. Destroyers were expensive assets, difficult to replace, essential for fleet operations. Using them for routine supply runs was inefficient and dangerous. The solution was simple: replace destroyers with barges for routine supply missions. Barges moved slower but presented smaller targets, operated in shallower water where PT torpedoes could not reach them, and cost significantly less to build and crew. A destroyed barge represented minimal loss. A destroyed destroyer was a strategic defeat. The first all-barge convoy ran on September 12, 1942. 23 Daihatsu barges departed from Buin on Bougainville, carrying supplies and reinforcements for Guadalcanal. PT boats from Squadron 3 intercepted the convoy off Savo Island in darkness. 6 boats launched 22 torpedoes in multiple attack runs. 0 hits. The torpedoes passed beneath every target. The barges scattered temporarily, then regrouped and continued their mission. 20 of 23 barges reached Guadalcanal successfully, delivering their cargo without significant interference. Each PT boat carried twin .50 caliber Browning machine guns in powered turrets mounted on the stern and amidships. The M2 Browning was an effective weapon, firing 850 rounds per minute with an effective range of 1,800 yards against aircraft and light surface targets. Against wooden fishing boats or unarmored patrol craft, the .50 caliber proved devastating. Against armored Daihatsu barges, it accomplished nothing measurable. Japanese naval architects had designed the Daihatsu specifically for contested amphibious landings under fire. The barges featured quarter-inch steel plate armor protecting the bow ramp, sides, and engine compartment. The armor was sufficient to stop rifle-caliber rounds completely. 50 caliber armor-piercing rounds could penetrate at very close range, under 200 yards, but PT boats rarely closed to that distance before concentrated Japanese return fire forced withdrawal or caused casualties. Some PT boat commanders attempted to mount single-shot Army M337mm anti-tank guns on their bows as improvised armament. The installation process was crude. Crews removed the gun's wheels, lashed the weapon to timber planks with rope, and secured the entire assembly to the deck. The guns could fire 1 round, then required manual reloading while under fire, a process requiring approximately 20 seconds of complete exposure to enemy fire. PT-109, commanded by Lieutenant John F. Kennedy, mounted an M3 anti-tank gun before a patrol on August 1, 1942. The gun fired successfully during an engagement with a Japanese barge off Kolombangara Island. The single 37mm round struck the barge's hull, penetrating the quarter-inch armor plate. Before Kennedy's crew could reload the weapon manually, the barge's Type 92 machine gun raked PT-109's deck with sustained fire. Torpedoman Second Class Andrew Jackson Kirksey took two 7.7mm rounds in the chest and died before the boat could withdraw from the engagement. Kennedy ordered the anti-tank gun removed immediately upon returning to base. The tactical exchange was completely unacceptable. 1 round fired, 1 sailor killed, minimal damage to the target. By mid-October 1942, Motor Torpedo Boat Squadron 3 had lost 6 boats in combat operations around Guadalcanal. 17 sailors had died in these engagements. Japanese barge traffic continued completely unimpeded, delivering approximately 400 troops and 60 tons of supplies per week to reinforce positions on Guadalcanal. American commanders faced a simple mathematical problem with profound strategic implications. PT boats could not sink barges with existing weapon systems. Until that fundamental problem was solved, Japanese forces would continue receiving reinforcements indefinitely, and the battle for Guadalcanal would continue without resolution. The doctrine was wrong. The weapons were inadequate. The tactics were failing. Something had to change, or PT boats would continue dying uselessly in the waters around Guadalcanal, while Japanese barges delivered the supplies and troops that would kill American Marines fighting inland. October 1942 would bring that change, born from desperation and innovation rather than institutional planning. Henderson Field occupied a rectangular clearing 3 miles inland from Lunga Point on Guadalcanal's northern coast. Marines had captured the partially completed Japanese airfield on August 7, 1942, during the initial landing operations. By October, the field functioned as a forward operating base for American aircraft, though the term "functioned" considerably overstated its actual condition and operational capacity. The runway measured 3,800 feet of compacted coral and dirt, graded by Navy Seabees working under constant threat of Japanese artillery fire from positions in the surrounding hills. The surface was adequate for fighter operations in dry weather, but deteriorated rapidly during tropical rainstorms that turned the coral to mud and created craters that required constant maintenance. Japanese bombing raids struck Henderson Field almost daily with methodical precision. Mitsubishi G4M Betty bombers approached at 20,000 feet altitude, well beyond the effective range of American anti-aircraft guns positioned around the field's perimeter. The bombers flew in tight formation, releasing their ordnance on predetermined coordinates, systematically destroying parked aircraft, fuel dumps, ammunition stores, and maintenance facilities. The raids occurred with such regularity that American personnel could predict their timing within 30-minute windows. 0 fighters accompanied the bomber formations, providing escort against American interceptors. After the bombers completed their runs, the Zeros descended to strafe Henderson Field at dawn and dusk, when low sun angles made them difficult to track visually. The strafing attacks killed ground crew members, damaged dispersed aircraft that had survived the bombing raids, and destroyed equipment positioned too far from protective revetments. Wrecked aircraft surrounded the runway in various states of destruction, creating a graveyard of American aviation assets. Some aircraft had crashed on landing with battle damage, engines smoking, hydraulic systems failed, control surfaces shot away. Some had been destroyed in their protective revetments during direct hits from Japanese bombs. Others had simply failed mechanically under the extreme conditions of South Pacific operations. Engines seized in tropical heat that exceeded design specifications. Hydraulic systems degraded from humidity levels that corroded seals and contaminated fluid. Electrical systems failed as salt air corroded connections and insulation deteriorated. The environment consumed aircraft as effectively as enemy action. Among the wrecks scattered across Henderson Field, Bell P-39 Airacobra fighters predominated in both number and visibility. The Army Air Forces had deployed P-39s to the South Pacific Theater in April 1942, expecting to employ them as interceptors against Japanese bomber formations. The aircraft failed catastrophically in that intended role due to fundamental design limitations that became apparent only under combat conditions. The P-39's Allison V-1710 engine sat behind the pilot's seat rather than in the conventional nose position. The engine connected to the propeller through a long drive shaft that ran beneath the cockpit floor. This unconventional configuration had been chosen by Bell Aircraft's designers to allow installation of heavy nose-mounted armament, but it created severe aerodynamic problems that limited high-altitude performance. The drive shaft added weight and mechanical complexity. The engine's rear position affected the aircraft's center of gravity and required aerodynamic compromises in fuselage design. At 20,000 feet altitude, where Japanese Betty bombers typically operated during their raids on Henderson Field, the P-39 struggled to climb and maneuver effectively. The Allison engine's single-stage supercharger could not maintain power output at high altitude. The aircraft's rate of climb decreased dramatically above 15,000 feet, making it nearly impossible to intercept bombers before they released their ordnance and turned for home. American pilots attempting high-altitude interceptions found themselves outclimbed and outmaneuvered by Japanese aircraft operating in their optimal performance envelope. By August 1942, squadron commanders had relegated most P-39s at Henderson Field to ground attack missions. The aircraft proved more effective strafing Japanese positions, supporting Marine infantry advances, and attacking coastal supply barges during daylight hours. The P-39's heavy armament was well suited for ground attack, and its performance limitations mattered less at low altitude. But ground attack missions exposed pilots to concentrated anti-aircraft fire from Japanese positions equipped with multiple machine guns and light cannons. 39 losses mounted steadily through September and into October. By October 20, 1942, 23 wrecked Airacobras littered Henderson Field. Their fuselages lay scattered across the coral in various stages of salvage and deterioration. Some were relatively intact, damaged primarily by anti-aircraft fire or mechanical failure. Others had been destroyed in Japanese bombing raids, their airframes broken and burned. The wrecks represented significant investment in aircraft production and pilot training, now reduced to scrap metal baking in the tropical sun. The P-39's most distinctive feature, and the primary justification for its unconventional design, was its primary armament, a 37mm Oldsmobile M4 automatic cannon firing through the propeller hub. Bell Aircraft's engineers had placed the cannon in the aircraft's nose, taking full advantage of the space created by moving the engine to the rear. The weapon represented the heaviest single armament ever installed in an American fighter aircraft at that time, significantly exceeding the firepower of the .50 caliber machine guns carried by most contemporary fighters. The M4 cannon fired 37 by 145 mm SR ammunition at a cyclic rate of 150 rounds per minute. Each high-explosive round weighed 1.3 pounds and contained 1.6 ounces of explosive filler designed to detonate on impact. The weapon had been designed specifically to destroy light armor and aircraft structures, precisely the same quarter-inch steel plate armor that protected Japanese Daihatsu barges from .50 caliber machine gun fire. The cannon's specifications were impressive on paper. Muzzle velocity of approximately 2,000 feet per second gave the weapon effective range exceeding 800 yards against surface targets. The high explosive rounds would penetrate armor plate that stopped rifle-caliber ammunition completely. The automatic firing mechanism allowed sustained engagement without manual reloading between individual shots. Every technical characteristic suggested the weapon would be devastatingly effective against the lightly armored barges that PT boats were failing to destroy with existing armament. Maintenance crews at Henderson Field had systematically stripped useful components from the wrecked P-39s throughout September and October as part of standard salvage operations. Instruments were removed and installed in other aircraft needing replacements after combat damage. Radios, control cables, hydraulic pumps, oxygen systems. Anything functional was salvaged and reused to keep flyable aircraft operational. The salvage priority reflected simple mathematics. Every component recovered from a total loss could extend the service life of a damaged aircraft that could still fly. Nobody had touched the 37mm cannons. They remained in the wrecked fuselages, intact and functional, but completely ignored by salvage teams. The reasoning was straightforward. The cannons were aircraft weapons, designed for installation in P-39 fighters, useless without an aircraft to mount them on. No doctrine existed for employing aircraft cannons in other roles. No mounting systems existed for alternative platforms. The weapons sat abandoned in 23 wrecked fuselages, representing thousands of pounds of functional armament that served no purpose. Lieutenant Robert Lynch walked Henderson Field at dawn on October 20, 1942, studying the P-39 wrecks with specific purpose. 26 years old, commissioned from the United States Naval Academy in 1940, Lynch had commanded PT-48 for 14 combat patrols without achieving a single confirmed kill. The statistic was not unusual. Most PT boat commanders in Squadron 3 faced similar records because existing weapons could not accomplish assigned missions. Lynch's boat had launched 16 Mark 8 torpedoes at Japanese targets during those 14 patrols. All 16 torpedoes had either missed completely or malfunctioned due to depth settings inappropriate for shallow draft targets. The torpedo attacks had consumed expensive ordnance while accomplishing nothing. 3 nights earlier, on October 17th, Lynch's crew had engaged 2 Japanese barges with .50 caliber machine guns at 400 yards range, closer than doctrine recommended, but necessary to have any chance of penetration. The armor-piercing rounds had sparked off the quarter-inch steel plate armor, creating visible impacts but causing no significant damage. The barges had completed their supply run successfully, delivering troops and ammunition to Japanese positions on Guadalcanal. Lynch stopped beside a particular P-39 wreck with its nose section buried in coral. The aircraft had crashed 3 weeks earlier in a wheels-up landing after taking anti-aircraft damage during a low-level attack near Cape Esperance. The pilot, Second Lieutenant Thomas Crawford, had survived the crash landing and returned to flight status after 2 days of observation for possible concussion. The airframe had not survived. The impact had broken the fuselage behind the cockpit and crumpled the landing gear beyond repair. But the nose section remained intact, and the 37mm cannon protruded from the propeller hub, visibly undamaged and potentially functional. Lynch crouched beside the weapon, examining the mounting system with the practical eye of an engineer. 8 high-tensile steel bolts secured the cannon to the engine's reduction gear housing. Hydraulic lines ran from the weapon to the aircraft's hydraulic system, operating the recoil mechanism. Electrical cables connected to the firing solenoid, allowing the pilot to trigger the weapon. The installation appeared complex, with multiple systems integration, but not impossible to remove with proper tools and knowledge of the aircraft systems. He performed mental calculations based on observable facts and technical knowledge. The M4 cannon fired 150 rounds per minute, 5 times the firepower of the single-shot M3 37mm anti-tank gun that some PT boat commanders had attempted to mount. Automatic fire meant sustained engagement without manual reloading between shots, eliminating the 20-second vulnerability window that had proven fatal during previous attempts. High-explosive rounds with 1.6 ounces of filler would penetrate quarter-inch armor plate at ranges exceeding 800 yards, possibly effective at 1,000 yards under ideal conditions. A PT boat equipped with this weapon could engage Japanese barges at tactical distances that minimized exposure to return fire. The boat could deliver concentrated automatic fire, destroying targets with multiple hits rather than single shots. The crew could withdraw before Japanese machine guns achieved effective suppressive fire. The tactical advantage was obvious and potentially decisive. The tactical concept was sound, based on weapon specifications and combat requirements. The engineering challenge was significant and carried substantial risk. PT boats had no mounting points designed for aircraft cannons. The weapon weighed approximately 280 pounds without ammunition, manageable for installation, but the recoil forces generated by automatic fire would stress any improvised mount severely. A poorly designed mount could fail catastrophically under combat loading, tearing free from the deck and potentially injuring crew members or damaging the boat's structure. Installation would require fabrication of a custom mount, modification of Navy property without formal authorization, and testing under combat conditions rather than controlled evaluation. Failure could result in multiple negative outcomes: equipment damage that would remove PT-48 from operational status, crew casualties from mount failure or premature weapon discharge, and potential court-martial for unauthorized modification of government property. The risks were real and substantial. At 1400 hours on October 20th, Lynch entered Commander Alan Calvert's office at the PT boat base on Tulagi. Calvert commanded Motor Torpedo Boat Squadron 3, 12 boats operating in increasingly desperate circumstances against an enemy they could not effectively engage. Squadron losses were mounting steadily. Barge interdiction missions were failing systematically. Higher commands expected positive results that existing weapon systems could not deliver. The pressure on Calvert to produce results was intense and growing. Lynch's request was direct and specific: permission to salvage 37mm cannons from wrecked P-39 aircraft at Henderson Field and mount them experimentally on PT-48's bow. The proposal violated numerous Navy regulations and procurement procedures. Standard weapons procurement followed established institutional channels. Bureau of Ordnance approved equipment based on testing and evaluation. Contractors manufactured weapons to approved specifications. Supply depots distributed equipment through logistics systems. Field modifications required formal engineering review, comprehensive safety analysis, and written authorization from appropriate commands. None of those processes would occur in time to matter for current operations. Calvert listened to Lynch's complete tactical analysis without interruption. He examined the rough sketches Lynch had drawn, showing possible mounting configurations and installation approaches. He considered the realistic alternative: continuing ineffective patrols with weapons that demonstrably could not accomplish assigned missions while losses continued and Japanese reinforcements reached Guadalcanal unimpeded. The decision required approximately 30 seconds of consideration. Permission granted. Verbal authorization only, with no written orders that could create institutional liability. If the modification succeeded and proved effective in combat, Calvert would claim command initiative and support the innovation through official channels. If the modification failed catastrophically with equipment damage or casualties, Lynch would face sole responsibility for unauthorized actions. Both men understood the arrangement completely. Both accepted the terms without hesitation because combat necessity outweighed institutional risk. By 1630 hours on October 20th, 4 PT boat crews were walking Henderson Field with cutting torches, socket wrenches, and salvage equipment. They had until nightfall, approximately 4 hours, to remove at least one functional cannon from a wrecked P-39 and transport it to Tulagi for installation. Japanese barges would be running supply missions that night, as they did every night. PT-48 would intercept them according to standard patrol assignments. This time, the Americans would bring a weapon that could actually destroy the targets they were ordered to engage. Technical Sergeant James Coogan had maintained P-39 aircraft at Selfridge Field, Michigan, for 18 months before his transfer to Henderson Field in July 1942. He knew the Airacobra's systems with the precision that comes from repetitive maintenance under peacetime conditions. Every hydraulic line, every electrical connection, every structural mounting point committed to memory through hundreds of procedures. When Lynch's crew arrived at Henderson Field at 16:30 hours on October 20th, requesting assistance removing M4 cannons from wrecked aircraft, Coogan became their essential asset. He possessed knowledge that no amount of cutting torches or determination could replace. The exact sequence for disconnecting systems without causing damage, the specific tools required for each fastener, the hidden complications that would trap inexperienced salvage teams. The first P-39 they approached sat 200 yards from the runway's eastern edge, positioned where it had stopped after crash landing 3 weeks earlier. The aircraft had taken a 20mm cannon round through the cockpit on September 28th during a low-level strafing run against Japanese positions near the Guadalcanal River. Second Lieutenant Thomas Crawford had died instantly when the shell detonated. Nobody had moved the wreck because salvage priorities focused on aircraft that could potentially return to service. Coogan crawled into the nose section, carrying a socket wrench set and diagrams he had sketched from memory during the truck ride from Tulagi. The M4 cannon mounted to the engine's reduction gear housing with 8 bolts, 7/8-inch diameter, high-tensile steel, manufactured to specifications that required specific torque values for proper installation. Removing them required disconnecting the hydraulic recoil system first to prevent fluid spray under residual pressure. 2 hydraulic lines carried fluid between the cannon's recoil cylinder and the aircraft's main hydraulic reservoir, located behind the cockpit. Coogan loosened the fittings carefully, releasing pressure gradually by cracking the connections in quarter-turn increments. The process took 12 minutes per line, slow work that prevented the sudden fluid release that could spray hydraulic oil across hot metal surfaces near welding operations and create fire hazards. The ammunition feed chute connected the cannon to the magazine bay, a curved metal tube that guided rounds from the horseshoe magazine to the weapons chamber. Coogan disconnected it at both ends, removing the mounting clamps and setting the tube aside. The component was undamaged and potentially useful for future installations, worth preserving despite time pressure. The firing solenoid required cutting 2 electrical cables. Coogan used wire cutters, leaving sufficient length for potential reconnection, maintaining salvage discipline even under combat urgency. The mounting bolts presented the primary challenge. Each bolt required a 15/16-inch socket for removal. Coogan's toolset included a 3/4-inch socket, close enough in diameter to engage the bolt heads, but loose enough to slip under heavy torque. He worked each bolt carefully, applying steady pressure rather than forcing the connection, preventing the socket from rounding off the bolt heads and making removal impossible. The 8th bolt released at 17:22 hours. Coogan and 2 sailors lifted the cannon free from its mounting, careful to support its weight evenly to prevent damage to the hydraulic recoil cylinder. The weapon weighed 213 pounds without its mounting bracket. 3 men carried it awkwardly but successfully to the coral surface beside the aircraft, laying it on canvas salvaged from a damaged tent to prevent coral dust from entering the mechanism. The second aircraft presented immediate complications. The P-39 had been sitting in tropical heat for 11 days following a wheels-up landing that had destroyed the landing gear and crumpled the lower fuselage. Hydraulic fluid in the recoil system had congealed from sustained exposure to temperatures exceeding 95 degrees Fahrenheit. The charging cable had corroded where salt air reached exposed copper through damaged insulation. When Coogan's team attempted to remove the mounting bolts, they discovered heat expansion had seized the threads completely. Henderson Field's supply depot had no penetrating oil in stock. Maintenance crews had exhausted their supply in August during intense salvage operations following the initial marine landing. Coogan improvised a solution based on field experience and mechanical understanding. He poured aviation gasoline over the seized bolts, allowing the fuel to work into the threads through capillary action. The solution was crude and created obvious safety hazards. Gasoline vapors near cutting torches represented serious fire risk, but alternatives did not exist within available time and resources. 20 minutes after applying gasoline, Coogan tested the bolts with a pipe wrench. The first bolt turned with sustained pressure. The threads had loosened sufficiently for removal. The remaining 7 bolts followed. The process worked, validating the improvised approach despite its dangers. At 18:47 hours, the second cannon lay on the coral beside the first. By 18:30 hours, 3 M4 cannons had been extracted from wrecked P-39 aircraft and positioned for inspection. Coogan examined each weapon systematically, checking components against a mental checklist developed through hundreds of maintenance procedures at Selfridge Field. His inspection was thorough, despite time pressure, because installing a defective weapon on PT-48 would accomplish nothing except wasting the effort already invested. The first cannon's hydraulic recoil cylinder showed a hairline fracture along the upper seam, barely visible to casual inspection, but obvious under focused examination. The crack likely resulted from impact forces during the crash that destroyed the aircraft. Under firing pressure, the fracture would leak hydraulic fluid, degrading recoil absorption and potentially causing complete system failure. The weapon was unusable for immediate installation, but could potentially be repaired given time and parts. Coogan marked it for salvage and moved to the second weapon. The second cannon's feed mechanism had a bent pawl in the magazine interface, the spring-loaded component that advanced rounds from the horseshoe magazine into the firing chamber. The damage was minor and repairable with a file and approximately 30 minutes of careful metalwork to restore proper geometry. But 30 minutes exceeded available time before nightfall. Coogan set the weapon aside for future salvage operations when time permitted proper repair. The third cannon was pristine. Every component was intact, every seal functional, every mechanical system operating as designed. The hydraulic recoil cylinder showed no damage. The feed mechanism cycled smoothly when tested by hand. The barrel was clean, the rifling sharp. This weapon would go to PT-48 for immediate installation. Coogan tagged it with a strip of cloth torn from his shirt, marking it clearly for transport, to prevent any possibility of confusion with the damaged weapon. PT boats had been designed and constructed with specific weapon systems in mind, each with engineering calculations defining structural requirements. Twin .50 caliber machine guns in powered turrets generated known recoil forces. 20mm Oerlikon cannons on deck mounts had defined weight and structural loading. 4 Mark 8 torpedoes in tube launchers required specific mounting strength. Every weapon had engineered mounting points calculated for weight, recoil forces, and structural loading under combat conditions and heavy seas. Nobody had calculated mounting points for a 280-pound aircraft cannon firing 150 rounds per minute at cyclic rate. The design requirement did not exist in any Navy engineering manual because the concept had never been considered. PT boats were torpedo platforms, not gun platforms. The structural loading from an automatic cannon exceeded anything the boat's designers had anticipated or planned for. The bow deck forward of PT-48's chart house consisted of 3/4-inch plywood over oak stringers spaced on 2-foot centers, standard construction for Elco 80-foot boats manufactured in Bayonne, New Jersey. Navy engineers had designed this structure to support foot traffic, light equipment storage, and the dynamic forces generated by the boat planing across waves at 40 knots. The deck flexed under wave impact, distributing stress across the oak framing. It had never been intended to absorb the concentrated recoil forces of an automatic cannon firing high-explosive shells. Lynch needed a mount that could accomplish 3 essential and potentially contradictory functions. First, absorb recoil forces without transmitting destructive stress to the wooden hull structure. Second, allow 360-degree rotation for engaging targets at any bearing relative to the boat's heading. Third, survive the structural flexing that occurred when a PT boat's hull worked through heavy seas at high speed. The mount needed to be engineered, fabricated, and installed in less than 6 hours using only resources available at Henderson Field. Henderson Field's machine shop occupied a corrugated metal building positioned near the fuel depot, approximately 300 yards from the runway's western end. The facility contained 1 lathe manufactured in 1936, 1 drill press with a chuck worn from extensive use, and a welding rig powered by a diesel generator that ran inconsistently due to fuel quality issues and inadequate maintenance. The shop had been established specifically to support aircraft maintenance operations, fabricating replacement brackets, repairing damaged propeller hubs, building custom engine mounts for aircraft that required field modifications. Chief Machinist's mate, Donald Frey, supervised the machine shop. 41 years old, with 22 years of Navy service, Frey had fabricated equipment and solved mechanical problems at every duty station from Norfolk to Pearl Harbor. He had worked with inadequate tools, insufficient materials, and impossible deadlines throughout his career. The current requirement, building a naval gun mount in 6 hours using salvaged materials, was challenging but not unprecedented in his experience. Frey examined the M4 cannon that Coogan had delivered, mentally calculating weight distribution and recoil vectors based on the weapon's dimensions and known firing characteristics. The design formed in his mind within minutes, emerging from 2 decades of practical experience with mechanical systems under stress. He sketched the concept on a sheet of aluminum using a grease pencil, simple lines and dimensions that translated abstract mechanical requirements into buildable physical reality. The base plate would be steel, 12 inches in diameter, with 4 bolt holes matching PT-48's deck framing pattern that Lynch's crew had measured and reported. A vertical pipe section welded to the base plate center would provide the rotating axis, simple, strong, and buildable with available materials and tools. A collar with machined bearing surfaces would slide over the pipe, allowing rotation while supporting the cannon's weight. A yoke fabricated from steel angle iron would cradle the cannon and provide elevation and depression through simple pivot points. Every component would be fabricated from scrap steel salvaged from destroyed aircraft scattered around Henderson Field. Landing gear struts provided high-strength steel already heat-treated for structural loading. Engine mounts offered heavy sections suitable for the base plate. Structural members cut from wrecked fuselages supplied material for the yoke and collar. The entire mount would cost nothing except labor and time because every component came from aircraft already written off as total losses. Frey's team began welding at 18:15 hours. The diesel generator powering the arc welder ran inconsistently because Henderson Field was rationing fuel severely. Japanese bombing raids had destroyed 2 fuel dumps in October, reducing available diesel to critical levels that forced rationing across all operations. The welders worked in 5-minute intervals, completing a series of welds before pausing to let the generator cool and prevent overheating that would cause complete failure. The base plate required 40 minutes of welding time, spread across 90 minutes of elapsed time due to generator cooling intervals. The steel was 3/8 inch thick, cut from a P-39's main landing gear housing using a cutting torch. Each weld had to achieve full penetration to create structural integrity capable of withstanding recoil forces. Frey inspected every weld bead personally using visual examination and simple physical testing, rejecting 2 sections that showed porosity, small gas bubbles that would create weak points under stress. He ordered those sections ground out and re-welded correctly. The vertical pipe section took 30 minutes of actual welding time. The pipe came from aircraft hydraulic system tubing, 2 inches in diameter with 1/4-inch walls, providing strength without excessive weight. Frey welded it to the base plate's exact center, ensuring perfect perpendicularity by checking repeatedly with a machinist's square. Any deviation from 90 degrees would cause the cannon to cant when rotated, throwing off aim and creating uneven stress distribution on the mount that could cause premature failure. The rotating collar presented the most complex fabrication challenge, requiring precision machining rather than simple welding. The collar needed to fit over the vertical pipe with minimal clearance, tight enough to prevent wobble that would degrade accuracy, loose enough to rotate freely under combat conditions when the mechanism would be stressed by recoil forces and possibly contaminated by salt spray. Frey machined the collar on the lathe, working from a solid steel cylinder salvaged from a damaged propeller hub. At 2100 hours on October 20, 1942, the mount was complete. Total fabrication time measured 3 hours and 45 minutes of actual work spread across 4 hours and 45 minutes elapsed time. The assembly weighed approximately 90 pounds, light enough for crew members to handle, heavy enough to provide stability. It looked exactly like what it was, something built in a field workshop under combat conditions by skilled craftsmen working with inadequate tools and salvaged materials. It would either function perfectly or fail catastrophically. Testing would occur in combat, not in controlled conditions. A 6x6 truck transported the cannon and mount from Henderson Field to Lunga Point Dock at 21:45 hours on October 20, 1942. 3 sailors rode in the truck bed, holding the cannon assembly to prevent it from bouncing on the rough coral road that connected the airfield to the coast. The road had been graded by Navy Seabees in August during initial construction operations, but 2 months of heavy vehicle traffic and tropical rainfall had degraded it to a rutted track that averaged 12 miles per hour for the 3-mile journey. PT-48 waited at Tulagi, positioned across Iron Bottom Sound from Guadalcanal's northern coast. A Higgins boat ferried the equipment across the water at 22:30 hours, navigating by compass bearing in near-total darkness. The sound was calm that night, no wind, no significant wave action, visibility limited to several hundred yards in ambient starlight filtered through cloud cover. Japanese destroyers occasionally shelled Tulagi at night, firing from positions northwest of Savo Island, but intelligence reports indicated no enemy surface forces in the area that evening. The Higgins boat made the crossing without incident, arriving at Tulagi's dock at 22:47 hours. Lynch and his crew had spent the evening preparing PT-48's bow deck for the cannon installation. They had measured the oak framing beneath the plywood deck surface, identifying 4 points where doubled framing provided maximum structural strength. These locations would receive the mounting bolts that would secure the base plate to the boat's structure. The crew had marked the positions with chalk, knowing that placement errors would compromise the mount's stability and potentially cause catastrophic failure under the stress of sustained automatic fire. Installing the base plate required drilling 4 holes through 3/4 inch of marine plywood and 2 inches of solid oak framing. The only tool available for this task was a hand-crank drill with a 3/4 inch bit, manual equipment that required sustained physical effort and careful technique to produce accurate results. Each hole required approximately 30 minutes of continuous cranking. One crew member operated the drill handle, another applied downward pressure to maintain bit engagement, and a third checked alignment constantly to ensure the holes remained perpendicular to the deck surface. Any deviation from perpendicular would cause the mounting bolts to seat improperly, creating uneven stress distribution that could tear the base plate free under recoil forces. The work proceeded slowly but carefully. At 0:15 hours on October 21, 1942, all 4 mounting holes were complete. The crew lifted the base plate into position, aligning its bolt holes with the freshly drilled openings in the deck. 4 mounting bolts, each 1/2 inch in diameter, were inserted through the base plate, through the plywood deck, through the oak framing, and secured beneath with heavy washers and lock nuts. The crew tightened the bolts in a star pattern, alternating between opposite corners to ensure even pressure distribution across the base plate. This technique prevented warping and maintained the base plate's position perpendicular to the deck. When fully tightened, the base plate seated firmly against the deck with no detectable movement when tested by hand. The foundation was secure. Now came the critical moment, mounting the cannon itself. The complete cannon and mount assembly weighed 370 pounds. 6 crew members lifted it together, coordinating their movements to prevent dropping the expensive and potentially fragile mechanism. They positioned the assembly over the installed base plate. The vertical pipe section that formed the mount's rotating axis slid through the collar's machined bore. The fit was tight but functional, exactly as Chief Fry had intended when he machined the collar at Henderson Field. The cannon elevated and depressed through its full range of motion without binding. It rotated 360 degrees, though not smoothly. The bearing surfaces required break-in under actual use, and some friction was inevitable with field-fabricated components. Ammunition storage presented an unsolved problem that had received insufficient attention during the rush to fabricate and install the mount. The M4 cannon used horseshoe-shaped magazines holding 30 rounds each. These magazines had been designed specifically for the P-39 aircraft, mounting in an internal magazine bay located behind the cockpit where the pilot could access them through a mechanical feed system. PT-48 had no magazine bay, no internal storage system, no quick reload mechanism of any kind. The solution adopted was purely improvised and acknowledged as inadequate even by the crew implementing it. 6 loaded magazines were stacked on the deck beside the gun mount, each magazine secured with a single rope loop tied to a deck cleat to prevent them from sliding when the boat maneuvered at high speed or took evasive action. In combat, a loader would hand each magazine to the gunner manually. The process would be slow, expose the loader to enemy fire, and create vulnerability during the 8-second reload interval. But no better solution existed within the time available before the night's patrol mission. Functionality mattered more than elegance or safety under current operational circumstances. The cannon was mounted. The base plate was secure. Ammunition was available. Whether the entire improvised system would work in actual combat remained completely unknown. At 200 hours on October 21, 1942, PT-48 possessed the first aircraft automatic cannon ever installed on a United States Navy patrol torpedo boat. The entire process, from initial concept to complete installation, had required 9 hours and 30 minutes. The weapon had never been test-fired from its mount. The crew had received no formal training on its operation. None of that mattered now. Japanese barges would be running supplies that night, and PT-48 would meet them. PT-48 departed Tulagi at 2200 hours on October 21, 1942, beginning what would become the most significant patrol mission in Motor Torpedo Boat Squadron 3's brief combat history. Squadron operations had assigned 4 boats to patrol duties that night. PT-40 and PT-46 covering waters north of Savo Island, where Japanese destroyers frequently operated. PT-48 and PT-60 patrolling off Cape Esperance, where barge traffic typically approached Guadalcanal. Standard formation executing a standard mission: intercept Japanese supply traffic attempting to reinforce garrison forces under cover of darkness. The night was overcast, with no moon visible through the thick cloud layer that had moved in from the southeast during the afternoon. Visibility measured approximately 200 yards in ambient starlight, sufficient for navigation but inadequate for visual target acquisition at tactical ranges. Sea state was calm, with wind less than 5 knots from the southeast, creating ideal conditions for small boat operations. PT-48 ran on 2 of its 3 Packard engines at 15 knots, a speed calculated to reduce noise signature and minimize the phosphorescent wake that could betray the boat's position to Japanese observers. The 3rd engine remained on standby, warmed and ready to deliver combat power if the tactical situation required high-speed maneuvering. Gunner's Mate 2nd Class Harold Mitchell sat behind the 37mm cannon on PT-48's bow, positioned on an ammunition box that provided adequate height for weapon operation. 23 years old, enlisted in the Navy in 1940, Mitchell had fired .50 caliber Browning machine guns on 12 previous combat patrols without achieving a single confirmed kill. The failures were not due to poor gunmanship, but to inadequate weapons. 50 caliber rounds could not penetrate the armor protecting Japanese barges. Mitchell had volunteered immediately when Lynch requested crew assignments for operating the untested cannon. Nobody else on PT-48 had volunteered. The weapon was completely unfamiliar, the mount appeared improvised and precarious, and the entire installation looked like it might tear free from the deck under sustained fire. Mitchell's training on the weapon had consisted of exactly 17 minutes of instruction from Technical Sergeant Coogan at the Tulagi dock immediately before PT-48's departure. The training covered only basic operational procedures: point the cannon at the target, Press the trigger mechanism. Release when the magazine empties after 30 rounds. The hydraulic recoil system would absorb most of the firing shock, probably. When the magazine emptied, remove it by pulling the horseshoe feed mechanism away from the weapon. Grab a fresh magazine, slam it onto the feed mechanism until it locked. 8 seconds if performed correctly under ideal conditions. Longer under combat stress with adrenaline degrading fine motor control. 6 loaded magazines sat on the deck within Mitchell's reach, each secured with a single rope loop that prevented sliding but allowed quick release. Mitchell had arranged them in specific sequence, positioning each magazine for optimal grab-and-load efficiency with his right hand, while his left maintained grip on the cannon. The entire arrangement was untested theory. Combat would reveal whether the improvisation functioned effectively or failed catastrophically under actual operational stress. At 23:55 hours, PT-48's radar operator detected surface contacts bearing 320 degrees at 4,000 yards range. 4 distinct contacts moving southeast at approximately 8 knots. The speed and formation characteristics were consistent with Japanese Daihatsu barges running supplies down the slot toward Guadalcanal, the exact targets PT-48 had been assigned to intercept. Lynch altered course to close the range, increasing speed to 25 knots to achieve intercept position before the barges could scatter or reach the relative safety of Guadalcanal's coastal waters. Standard American doctrine for PT boat attacks specified closing to 1,000 yards before launching torpedoes. The optimal torpedo firing range was calculated at 800 yards, close enough for accurate targeting with minimal torpedo runtime, distant enough to allow evasive maneuvering after launching and before enemy return fire became effective. The doctrine had been developed through peacetime exercises against conventional naval targets, destroyers, cruisers, cargo vessels with deep draft hulls that presented large target profiles. Against shallow draft barges drawing only 5 feet of water, the established doctrine was completely worthless. Torpedoes set at their minimum 10-foot depth would pass directly beneath the targets without making contact or detonating. Lynch needed to close within effective firing range for the 37mm cannon, but neither he nor Mitchell knew what that range actually was under combat conditions. The weapon had never been fired from a PT boat. Technical Sergeant Coogan had estimated 800 yards maximum effective range based on the cannon's documented performance against aircraft targets, but that estimate assumed a stable firing platform and clear visibility for aim correction. A PT boat's deck pitching and waves at night provided neither stability nor visibility. The actual effective range would be determined through combat experience, not theoretical calculation. At 3,000 yards range, Lynch could distinguish individual barge silhouettes against the slightly darker water beyond them. 4 Type A Daihatsu barges in line formation, each vessel measuring 49 feet in length with a 14-foot beam. The barges were powered by single diesel engines, producing maximum speed of 12 knots, slow by PT boat standards, but adequate for night supply runs in contested waters. Each barge carried a Type 92 heavy machine gun mounted amidships for defense against air and surface attack. The 7.7mm weapon was effective against unarmored targets at ranges up to 800 yards. The barges were clearly transporting troops rather than bulk supplies. Lynch could see the shapes of men sitting on the decks, darker masses visible against the gray-painted metal of the hulls. Approximately 60 men per barge based on the density of visible shapes, totaling 240 troops heading to reinforce Japanese positions on Guadalcanal. If those troops landed successfully and joined the garrison forces, they would be engaging American Marines in ground combat within 24 hours. Preventing their landing was PT-48's mission and justified the risks Lynch was about to accept. PT-48 closed to 1,500 yards. Mitchell charged the cannon using the manual charging handle mounted on the weapon's right side, a lever that retracted the bolt and compressed the firing spring. The mechanism operated smoothly despite having never been tested on the mount. The first round from the loaded magazine seated in the chamber with a solid metallic click audible even over the rumble of PT-48's engines. Mitchell flipped the safety lever from safe to fire position. The cannon was ready for combat. His hands were steady on the firing grips. Adrenaline sharpened his focus and heightened his sensory awareness rather than degrading his motor control. The positive stress response of an experienced combat veteran. At 1,000 yards, the lead Japanese barge detected PT-48's approach. The Type 92 heavy machine gun mounted amidships opened fire immediately, its tracer rounds drawing bright orange lines across the black water. The initial burst struck the water 30 yards short of PT-48's bow. The Japanese gunner had underestimated range in the darkness. Subsequent bursts walked closer as the gunner adjusted elevation, each correction bringing the fire closer to the target. The tracer rounds arced upward slightly at the apex of their trajectory before descending toward PT-48's position. Lynch maintained course directly toward the barges. Turning away now would abort the attack and waste the only opportunity to test the cannon under actual combat conditions. Every decision made over the past 14 hours, the salvage operation, the mount fabrication, the installation, led to this moment. Lynch was committed completely. The boat, the crew, the untested weapon system, all committed to an engagement whose outcome would determine whether PT boats could effectively combat Japanese barge traffic or continue dying uselessly in these waters while accomplishing nothing. Mitchell opened fire at 800 yards range. The 37mm cannon roared with a sound completely different from any weapon previously fired from a PT boat. The muzzle flash illuminated the entire bow deck in harsh white light, destroying Mitchell's carefully preserved night vision instantly. The recoil drove the gun backward in its mount, the hydraulic recoil system compressing to absorb the shock. The deck flexed visibly beneath the impact, the plywood surface bending under forces it had never been designed to withstand. The pedestal mount held without movement. The cannon fired successfully. Mitchell kept his finger pressed on the trigger mechanism, maintaining sustained fire. The M4 cycled at its designed rate of 150 rounds per minute, 2.5 rounds per second, creating a continuous hammering roar rather than individual shots. The horseshoe magazine held 30 rounds. Mitchell emptied the entire magazine in 12 seconds of continuous automatic fire. 30 37mm high-explosive rounds arced across 800 yards of dark water toward the lead Japanese barge at muzzle velocity of 2,000 feet per second. The rounds hit their target. Mitchell could not see the individual impacts clearly. His night vision was completely destroyed by muzzle flash, but he saw the effects clearly enough. Orange explosions rippled along the barge's waterline as high-explosive rounds detonated on impact. Each 37mm round converted its 1.6 ounces of explosive filler into blast and shrapnel upon contact with the steel armor. The first 3 rounds punched completely through the quarter-inch steel plate as though it were cardboard rather than armor. The 4th round penetrated the hull and detonated inside the crowded troop compartment. The barge's diesel fuel tank ignited seconds later. Orange flame erupted from the vessel's center section, illuminating dozens of men jumping desperately into the water to escape the spreading fire. The barge continued forward on momentum for approximately 50 more yards, trailing flame and black smoke. Then it settled noticeably by the bow as flooding overwhelmed the hull's buoyancy. The vessel stopped moving, dead in the water with crew and troops abandoning. No longer combat effective. The first target was destroyed. Mitchell yanked the empty magazine off the cannon. The horseshoe feed system released cleanly, exactly as the weapon had been designed to operate. He grabbed the second magazine from the deck beside him and slammed it onto the feed mechanism with both hands. The magazine locked into position with an audible click. The entire reload process took 8 seconds from magazine release to weapon ready. 8 seconds represented an eternity in combat, sufficient time for enemy machine gun fire to find its target and kill an exposed gunner. But the system worked. The magazine seated properly. The cannon was ready to fire again. The second Japanese barge in the formation turned hard to port, attempting to break away from the engagement and escape into the darkness beyond effective firing range. PT-48's helmsman followed the turn immediately, maintaining optimal firing position relative to the fleeing target. Lynch closed the range to 600 yards, accepting increased risk from Japanese return fire in exchange for higher probability of hits. Mitchell fired the second magazine without hesitation, 30 rounds in 12 seconds. 22 rounds struck the barge. Mitchell's aim had improved noticeably as he learned to compensate for the weapon's recoil behavior and the slight delay between trigger press and round impact. The barge's quarter-inch steel plate armor stopped the first 5 37mm high-explosive rounds that struck it. The armor performed exactly as Japanese naval architects had designed it to perform, deflecting the initial impacts and protecting the vessel's interior. But the sixth round found a seam where 2 armor plates joined along the hull's waterline. The round penetrated through the gap and detonated inside the hull. The seventh round followed through the same breach point, its high-explosive filler detonating among the crowded troops and stored ammunition. The barge exploded rather than simply catching fire. The blast was visible for miles across the dark water, a brilliant orange fireball that illuminated the surrounding area momentarily. Ammunition cook-off. The barge had been carrying ordnance in addition to troops, artillery shells, mortar rounds, rifle ammunition. When Mitchell's 37mm rounds penetrated the hull and detonated near these stores, the secondary explosion was catastrophic. The blast disintegrated the vessel completely. Fragments of metal and wood scattered across the water in all directions. No survivors were visible in the debris field. The third and fourth barges scattered immediately after witnessing the destruction of the first 2 vessels. One barge turned sharply north toward Savo Island, attempting to hide against the island's dark landmass where visual acquisition would be nearly impossible. The other barge turned south toward Guadalcanal, running at maximum speed for the coast where it might beach itself if pursued and potentially save its troops even if the vessel was lost. PT-48 could not engage both targets simultaneously with a single cannon. Lynch made the tactical decision to pursue the southern barge, the vessel still heading toward Guadalcanal, still attempting to complete its mission of delivering reinforcements to Japanese positions. Mitchell loaded his third magazine while the mount's rotating collar began binding noticeably from heat expansion. The bearing surfaces that Chief Frey had carefully machined at Henderson Field were already showing wear under the extreme stress of sustained combat firing. The bronze bushings were functioning but could not completely eliminate friction under these conditions. Mitchell had to use both arms to force the gun to rotate, muscling it around to track the fleeing barge despite the mechanical resistance. At 700 yards range, Mitchell fired the third magazine. The fleeing barge's crew returned fire desperately with their Type 92 heavy machine gun. 7.7mm rounds struck PT-48's bow, several impacts hitting the plywood deck. One round punched completely through the 3/4-inch plywood 18 inches from Mitchell's position. He heard the sharp crack of impact, felt the vibration transmitted through the deck structure beneath his feet, but did not stop firing. 30 rounds downrange in 12 seconds. The 37mm high-explosive rounds walked up the barge's hull from stern to bow as Mitchell adjusted his aim to compensate for the target's evasive maneuvering. The barge's diesel engine died suddenly, trailing black smoke from the engine compartment, where one or more 37mm rounds had penetrated and destroyed critical components. The vessel lost propulsion immediately and began drifting with the current, no longer under control. Men were abandoning the disabled barge, jumping into the water and swimming away rather than remaining aboard a crippled target that continued to draw fire. The barge did not sink. It had not taken sufficient hits below the waterline to breach the hull completely and overcome its buoyancy, but it was no longer combat effective by any measure. It would not reach Guadalcanal. The troops aboard would not reinforce Japanese defensive positions. PT-48 broke off the attack at 0020 hours on October 21, 1942. Mitchell had fired 90 rounds from the 37mm cannon during the engagement, 3 complete magazines. The weapon had not jammed, despite being fired for the first time from an improvised mount under combat conditions. The pedestal mount had not failed structurally, despite absorbing recoil forces it had never been tested to withstand. The plywood deck had not collapsed, despite flexing visibly under impacts it was never designed to handle. 2 Japanese barges were destroyed completely, with all hands lost. 1 barge was disabled and drifting, unable to complete its mission. Approximately 180 Japanese troops were confirmed dead or in the water. 0 American casualties. Lynch radioed Commander Calvert at Tulagi at 00:35 hours. The transmission was deliberately brief and factual, avoiding any emotional content or subjective assessment. PT-48 had engaged 4 Japanese barges using the salvaged aircraft cannon. The weapon worked. It worked considerably better than anyone had expected based on theoretical performance estimates. 2 barges destroyed outright, 1 barge disabled, 1 barge escaped. The weapon proved effective at ranges up to 800 yards under night combat conditions. Ammunition consumption was high, approximately 30 rounds per target required for assured destruction. Calvert's response was equally brief and professional. Return to base immediately for comprehensive debrief and thorough inspection of the cannon mount's structural integrity. Do not engage any additional targets until the mount could be examined by qualified personnel and certified safe for continued combat operations. Lynch acknowledged the order and set course for Tulagi at cruising speed. By 0300 hours, every PT boat commander in Motor Torpedo Boat Squadron 3 was demanding an M4 cannon for his boat. The radio traffic from PT-48 had been monitored across the entire squadron, standard procedure that allowed all boats to maintain tactical awareness. 2 Japanese barges destroyed in a single engagement, 0 American casualties. The mathematics were undeniable and compelling. The improvised weapon system worked effectively under actual combat conditions. The immediate problem was supply constraints. Henderson Field had 23 wrecked Airacobra fighters scattered across its perimeter. Squadron 3 operated 12 PT boats requiring armament. The simple mathematics did not favor complete distribution of cannons to every boat in the squadron. But Commander Calvert had already reached a command decision. Some boats equipped with effective weapons were operationally superior to all boats equipped with ineffective weapons that could not accomplish assigned missions. Salvage operations would resume at Henderson Field the following morning, October 22nd. Every usable M4 cannon would be systematically removed from wrecked aircraft. Chief Fry would fabricate additional pedestal mounts using the improved design that incorporated lessons learned from PT-48's combat test. Every available PT boat would be armed as rapidly as fabrication capacity and available cannons permitted. The improvisation that had begun with Lieutenant Lynch's observation at Henderson Field and Commander Calvert's verbal authorization had produced measurable, documented results in its first combat test. The results would ultimately transform PT boat operations throughout the South Pacific Theater, but that transformation would require months of additional development, systematic refinement, and gradual institutional acceptance through official channels. October 21, 1942, marked only the beginning of that process. By October 23, 1942, 3 additional PT boats had received 37mm cannons, PT-40, PT-46, and PT-60. Salvage crews had stripped 5 more wrecked Airacobras at Henderson Field in the 48 hours following PT-48's successful combat test. The salvage operation had transformed from experimental procedure to systematic process. Teams now understood precisely which bolts to remove first, which hydraulic lines required disconnection, which electrical connectors needed cutting. The learning curve had been steep, but the knowledge gained proved decisive for operational tempo. The second cannon removal took 90 minutes from initial approach to complete extraction. The third removal took 70 minutes. By the fourth extraction, the team had reduced the entire process to 55 minutes from first cut to weapon ready for transport. Speed mattered critically because Japanese bombing raids continued striking Henderson Field almost daily. Working near wrecked aircraft during daylight hours meant constant exposure to strafing runs by Zero fighters and fragmentation bombs from Betty bombers. Salvage teams learned to work with maximum efficiency and disperse immediately when air raid sirens sounded across the field. The pedestal mounts improved systematically with each successive installation. Chief Machinist's mate Donald Fry had personally examined PT-48's mount after the October 21st engagement, documenting every stress point, wear pattern, and potential failure mode he could identify. The rotating collar showed excessive wear that concerned him. The bearing surfaces had scored visibly from the cannon's recoil forces operating against inadequate lubrication and the primitive machining tolerances achievable with Henderson Field's worn equipment. Frey's solution drew on his 2 decades of practical mechanical experience. He added bronze bushings salvaged from damaged aircraft wheel assemblies, components designed to handle rotational stress under extreme loading conditions. The bushings reduced friction dramatically while distributing rotational stress more evenly across the bearing surfaces. Second-generation mounts incorporating these bushings rotated smoothly even under sustained combat loading. The improvement was measurable in practical terms. Gunners could track moving targets with approximately half the physical effort required on the original mount design. Ammunition supply became the immediate operational bottleneck, limiting combat effectiveness. Henderson Field's aviation armory maintained stockpiles of horseshoe magazines for P-39 aircraft, but these magazines had been designed specifically for aerial combat, where typical engagements lasted only seconds. PT-boat actions against Japanese barges could extend 20 minutes or longer. Mitchell had fired 90 rounds during PT-48's first engagement, a relatively brief action against a single barge convoy. Longer patrols engaging multiple convoys would require substantially more ammunition than could be carried practically on the limited deck space available. Aviation ordnance personnel at Henderson Field began loading magazines around the clock in continuous shifts to meet the surging demand. Each magazine required hand-loading 30 individual rounds. The 37mm shells arrived in wooden shipping crates, packed in thick cosmoline preservative that protected them during transport and storage. Each round had to be cleaned carefully to remove all cosmoline, inspected thoroughly for any damage that might cause malfunction, and seated properly in the magazine's horseshoe curve with correct spacing. The entire process took approximately 8 minutes per magazine when performed by experienced loaders working at sustainable pace. The armory maintained 4 trained loaders working 12-hour shifts in rotation. This workforce produced approximately 40 magazines per day under normal conditions. 4 PT boats, each carrying 6 magazines, required 24 magazines per patrol cycle. The boats typically ran 2 patrol missions per night when operational tempo was high and Japanese barge traffic was heavy. The mathematics barely worked even under ideal conditions. The loaders were producing just enough ammunition to sustain current operations, with no reserve capacity for increased engagement rates or equipment losses. T-40 engaged 3 Japanese barges off Kambo Bay on October 24, 1942. The boat's newly installed M4 cannon destroyed 2 barges completely during the first magazine, 30 rounds fired over 20 seconds of sustained automatic fire. Both barges were burning intensely and sinking within 2 minutes of initial contact. The third barge escaped into darkness before PT-40 could reload and engage, but subsequent radio intercepts suggested it had taken damage and possibly sank before reaching its intended destination on Guadalcanal. This engagement demonstrated conclusively that PT-48's success on October 21st was not anomalous or dependent on exceptional circumstances. The weapon system worked consistently across different boats, different crews, different tactical situations, and varying environmental conditions. The 37mm cannon fundamentally changed PT boat effectiveness against Japanese barge traffic in ways that existing armament could never achieve. Squadron 3 began developing new tactical doctrine based on systematic analysis of actual combat results rather than peacetime theory. Before the cannon installation, PT boats had attempted to employ torpedoes at long range, 800 to 1,000 yards. The torpedoes consistently missed shallow-draft barges, passing harmlessly beneath them. The PT boats would then withdraw without accomplishing their mission. With the 37mm cannon, PT boats could close aggressively to 400 yards and destroy barges with concentrated direct fire. The closer engagement range increased danger from Japanese return fire significantly, but it eliminated the fundamental problem of torpedoes passing underneath their intended targets. The tactical exchange was acceptable from a command perspective. Moderately higher risk was offset by dramatically increased combat effectiveness and mission success rates. PT boat casualties actually decreased rather than increased because engagements ended much faster. Barges sank or were disabled before their crews could establish effective suppressive fire against the attacking PT boats. Japanese commanders noticed the tactical change within days of its implementation. Radio intercepts from October 25th indicated that Japanese barge crews were reporting encounters with PT boats equipped with heavy cannon and explosive shells rather than the ineffective machine guns they had faced previously. One intercepted message used the specific phrase, "demon boats with aircraft guns," terminology that suggested significant psychological impact on Japanese personnel. Japanese barge crews had operated with relative impunity for weeks during September and early October. They understood from experience that American PT boats carried torpedoes that could not hit shallow-draft vessels and machine guns that could not penetrate quarter-inch armor plate. The barges had been effectively safe from PT boat attacks. Now they were being systematically destroyed before they could deliver their cargo. The certainty of safe passage had been replaced suddenly by high probability of destruction. By November 1, 1942, 8 PT boats in Motor Torpedo Boat Squadron 3 operated with salvaged 37mm cannons mounted on improved pedestal designs. Henderson Field had been completely stripped of every usable M4 cannon from wrecked P-39 aircraft. 21 cannons total had been removed through systematic salvage operations. 17 cannons were actively in service on PT boats conducting combat patrols. 4 cannons were held as critical spares for maintenance rotation when operational weapons required overhaul or repair. The success of this field modification reached higher commands through official after-action reports in mid-November. Commander Motor Torpedo Boat Squadron's South Pacific reviewed the documented results carefully. 8 combat patrols conducted by cannon-equipped boats, 23 Japanese barges engaged, 14 barges destroyed completely, 6 barges damaged sufficiently to abort their missions, 3 barges escaped. 0 PT boats lost in these actions. The statistics were definitive and compelling. PT boats equipped with 37mm cannons achieved combat results that were impossible with standard-issue armament. The field modification worked effectively under actual combat conditions. The question for higher command became whether to approve the modification officially through institutional channels or continue treating it as unauthorized field expedient that existed outside formal doctrine and procurement systems. This innovation began with a single observation at Henderson Field and ended as standard equipment on hundreds of PT boats across the Pacific. Lieutenant Lynch, Chief Frey, Technical Sergeant Coogan, and Gunner's Mate Mitchell solved a tactical problem that institutional processes had failed to address. Their solution saved lives and changed naval warfare. Thank you for watching. If you found this story valuable, subscribe to the channel. We continue recovering these forgotten moments from the archives. Real decisions, real consequences, real history.